Hello, my name is Lucas Vogeli, and this is my oral presentation for EE Science 2, Fall 2024. Today I'm going to talk about Faraday cages, and here we can see our friendly neighborhood DIY guy. These guys are always way too confident. So, what are Faraday cages? Faraday cages cancel electromagnetic waves using conductive material. Notice that I said we are canceling the waves, not blocking them, and we'll talk about that in a bit. So, in 1755, Benjamin Franklin observed that when he placed an uncharged cork ball in a charged can, there was no attraction to the can. Also, in 1836, Michael Faraday observed that conductors only have charges on their surface. In the present day, applications include scientific experiments, for example, MRI rooms. So when you need to reduce noise in measurements that require lots of accuracy, you might use a Faraday cage. Also, microwaves, you want to keep the waves inside of the device. There are also RFID blocking wallets to prevent your card from being scanned when you don't want it to. Car and plane frames are made out of metal and they can protect against lightning strikes. Also, we can see an image here of a Faraday cage being used to perform an experiment. Okay, so how do Faraday cages work? In the image in the top left, we see that our electrical component is inside of a conductor, and the conductor has free electrons spread out over the material. And then when you shoot an electromagnetic wave at it and it experiences some electric field, the electrons are going to move to one side, so they're going to pile up all over here. And this is going to create another electric field that's going to counteract the original one, and there's going to be no electric charge inside of the device. And this lines up perfectly with the boundary conditions that we've been talking about so much in this course. And in the bottom image here, we can see that there is no electric field inside of this conductor. Also, on the right, I noted that magnetic fields on their own will not get canceled. For example, the Earth's magnetic field, so your compass will still work inside of a Faraday cage. And this is because there are no magnetic charges. But this is okay because if there's no electric field, then there's no electromagnetic wave. So you'll be able to successfully block out your radio waves and everything like that. How do we make a good Faraday cage, and what parameters do we need to look at? First up is skin depth, relating to the thickness of the cage. So the skin depth is the depth at which the wave is going to attenuate significantly, and this is going to depend on the material's conductivity, permeability, and the frequency of the wave you're trying to cancel. Next is hole size. If you have holes in your material, then that is going to allow shorter wavelengths to pass through. And ideally, you want a hole diameter to be less than 1/10 of the wavelength you're trying to cancel. Finally, if we look at our equation down here, perfect conductors are going to have a resistivity of 0, so the skin depth is going to be 0, and that is going to show that no wave is going to get through, and the wave is going to decay immediately, which is what we want. Here are the references that I've used for this presentation. Thank you and have a nice day.